All right, so as if this wasn't complicated enough, we're trying to take a recursive solution and make it iterative so that we don't have a maximum recursion issue. Clear out all these errors I've been getting, and let's see if we can get this done. So the first thing I'm going to do is go into my node class, and I am going to take all this stuff out. I'm going to press Control KC, which will just comment it out. And this will make it so the toggle node only reveals, essentially. It doesn't do anything else. And then we're going to go to our reveal ancient nodes and adjacent nodes, and we're going to, instead of toggling them directly, we're going to load all of the toggleable ones into a new list. So we're going to create let new nodes, which is going to be a type node, equal an empty array. And then what we want to do is basically take this off, and we're going to say let temp node equal this. And then if temp node dot revealed but isn't revealed, we only want to try to flip it if it isn't revealed. Otherwise, we're going to still have a lot of problems with recursive logic. So if it's not been revealed yet, then we're going to add it to this new nodes list. So we're going to say new nodes.push temp node. And I can kind of copy this logic here and basically paste it under each of these. And then all I have to do is do let temp node equal, and then get rid of this toggle node on the end, and should be good. Let's keep doing that. Say let temp node equal this, delete this, and we still want these checks in place to make sure if we're on the edge of the board it's not going to cause any problems. Let temp node equal this. Here we go. Good. Let temp node equal, whoops, equal, yeah, I screwed up a little bit here. We got it though. Equal this, and then this, okay. Let temp node equal this, delete this, paste this, okay. And let temp node equal this, delete this, paste this, beautiful. Let temp node equal, whoops, I did it again. Equal this, delete this, and do this. And then at the very end, we're going to be returning our new nodes. And basically, this function is now going to be returning a list of nodes that we want to toggle, or that we can toggle all the adjacent nodes around it that exist that aren't already revealed. It's going to add it to a list of nodes to toggle. And we're actually going to handle the toggling outside of this now. So right now I have my A button toggling. I don't want that anymore, so I'm going to take this out. Actually, we're going to change this logic. So what I'm going to do is actually cut this out, and I'm going to put it inside of this. And we're going to create a new function called toggle node, and it's going to take a node as the argument. So let's go here. We're going to create function toggle node, and then we're going to have a node as the argument. Good. And then I'm going to build a new list with these nodes. It's going to start with only one node in it. So we're going to have let nodes to toggle list of nodes equal, and then we just put our node inside, or one node inside. And basically I'm going to keep adding and removing from this array until I don't have any more nodes to toggle. And the way that's going to work is going to look like this. We're going to say while nodes to toggle dot length is greater than 0. The first thing we're going to do is pop off. We're going to take this array and we're going to use the pop function. So we're going to say let temp node equal nodes to toggle dot pop. And what pop does is it removes the last element from an array and returns it, which means not only does it take the node out of the nodes to toggle array, but it assigns it to this value here. And now we can do whatever we need to here. The first thing we need to do is actually toggle this. Toggle node, good. And then the next thing we want to do is we want to count to see how many bombs are around it. So we're going to say temp node, if temp node dot count adjacent bombs equals 0. That's when we do all of the adjacent ones. So we're going to get some more nodes. We'll say let new nodes equal temp node. That function that we just built, the reveal adjacent nodes, is going to return that list of nodes to toggle. And now we want to take each one of these new nodes and add it to our nodes to toggle list. So we're going to say nodes to toggle. Well, JavaScript is weird. I'm just going to do this in kind of the easiest way to understand because I don't like a lot of the JavaScript logic for combining lists and stuff. So we're just going to do it the easy way. Let I equal 0. I is less than new nodes dot length I plus plus, and then why is this not good? Okay, and then what we'll do is nodes to toggle dot push new nodes I. So essentially we're taking all of those new nodes that we get, all of the ones that qualify in that they're adjacent to the current node and they haven't been revealed yet. And those ones are going to be added to this list again, and then it's going to repeat this process, popping them off and then adding more nodes until you're going to keep combining this list together. You shouldn't have any repeats because once it's revealed, and we don't have to worry about that anymore. So let's see if this, oh my gosh, it works. It actually works. That makes me very happy. Good. Good, okay. Good. Actually, do I know that for sure? I know that this one isn't. Ooh, there we go. Oh, this is a tricky one. It can be either of these, actually. We're gonna have to come back to that one, so. Anyway, this should prevent us from having any issues. So I don't need to complete this. I just wanted to, let's just click random stuff here. Oh my gosh, it has to be this. Saying I don't want to complete it and then trying to complete it in earnest. Here's gotta be, okay, that one's 2 already, so that one has to be it. This has to be, and yes, we won. Okay, good. All right. So the issue I was having before is, let's say I have 10 by 10, but I reduce my bombs down to 1. I would have crazy recursive logic, but now I don't. Now it fills up the screen. Now we can do all of these. Now, even if we were to go like, let's see, how many rows can we possibly fit? We could probably get 15 rows and 20 columns. So even if we did this giant one, oh my gosh, still, it's able to function correctly. I think I actually just put the perfect amount in there. Interesting. Yeah, so that's the biggest version we can play. Anyway, this was not super necessary for anything that you're working on for the project. It just, I hope this kind of shows how I approach this problem solving. If something comes up and you're dealing with a recursive problem and the recursive problem's causing memory errors, maximum recursion, stack overflows, that kind of stuff, then you have to find a different solution. And that's sort of the core of a field called dynamic programming. Most of dynamic programming is figuring out how to take recursive problems and transfer them to iterative problems, because recursive problems are usually very elegant and easy to read, but they're not as computationally easy on your computer, I guess. It's not as easy to run because it would require a lot of memory, a lot of stuff stored in memory, especially as it scales up. So now we've got an iterative solution, and it doesn't matter how much we scale up, we shouldn't have any issues. Hope that was fun. That was fun for me.